Okay, so we see this problem with the table. The first thing we want to do is just sort of read what this table is telling us. We've got the polynomial function f has the selected values of second derivatives. So what we know is what we're looking at up top here. These are second derivative bits of information. And I will tell you the first thing that pops into my head when somebody says second derivative is that I need to be talking something about concavity, whether that's concave up, concave down, inflection points. That type of language would sort of be bells and whistles for me. Now what I need to do is come and look at these statements down below, and don't you love these problems where they basically are like, look through 5 things and figure out which is true. It's it's one of their favorite games to play. So it's kind of like 5 little problems in this one big problem. So we're looking for the one that must be true. So we're looking for the good answer here. And always remember that this is always must be on these. Must be true, must be false. Could it be some of these other things? It could be, but we're not guaranteed that type of information. So we're looking for the one thing we're guaranteed by this chart of second derivative data. The next piece I do is I always make sure that like I'm looking at what function it is I'm talking about. Notice here that we're talking about the original function for these answers. So we need to be taking second derivative data and talking about the original function based upon that. Reading through the first problem, I see a word f is increasing on this interval. Whenever I see a word like increasing or decreasing, increasing and decreasing is a first derivative game, right? Whenever we've got positive first derivatives, that's when this graph would be increasing. And here we don't see any of that information. We just have second derivative information. I go to B, it's the same idea, right? This time they just happen to be talking about decreasing. And so anytime I see that word increasing and decreasing, I know that that's really a first derivative game, and that would be telling me when is the first derivative negative. So the first two are kind of off the table right now because that's first derivative data. Looking at C right now, f has a local maximum at x equals 2. When I talk about local maxes and mins, my first thought is again first derivative, because when we do that, we have the thing called the first derivative test, where if the graph is headed up and positive and down and negative, then we'd be looking at a max in that situation. So we again don't have any of that first derivative data, so that can't tell me the local max. I also would need to know that this right here is a critical value. Well, a critical value would be where my derivative at 2 equals 0. Well, I don't know that that's happening, right? Again, I've got second derivative data, and I know where the second derivative is equaling 0. However, I know nothing about where the first derivative is equaling 0. So that throws this one off. Then D says the graph of f has an inflection point at x equals 2. Okay, so an inflection point at x equals 2. What does the inflection point mean? The inflection point means the second derivative has to equal 0 or not exist at that point. And so I come in and I look and I say, okay, well, I have my second derivative data and it is telling me that it's equaling 0 at 2. And so, okay, I have that. That checks off. That's for sure happening right there. Then the other part of it is that it has to change concavity at that point. So it has to change, if you think about it in terms of a number line, right? At my inflection point, it's got to change from negative to positive second derivative data, so concave down into concave up, or it's got to change from positive to negative, so concave up into concave down. It needs to have changing in concavities in order for it to be an inflection point. And the trap on this, right, is this is a table of data. You don't know all the information. You only know these selected points. So you would come back up here and you're like, oh, well, I've got a positive on this side and a negative on that side, right? There's my plus minus change that I'm supposed to be able to see. Well, that's not telling you, this chart, remember, doesn't say that there's not another inflection point. So if 2 is sitting right here. There's nothing to say that like moving over here, I know it's not far because the next point's over at 1, but it's not telling us for sure that there's not a point right here at like 1.75 where it also equals 0. So we can't assume that that's the only one because it's just a table and we've only got limited amount of data. And so while that seems like a really good answer, we can't say with 100% certainty, which is what you need when it must be true. And so because of that, you're kind of saying, maybe on that one, but I'm not 100%. Then we go over to E. And again, this is where things get tricky. It's just saying on this one, the graph changes concavity in the interval from 1 to 3. So that we go up to our interval, and I would say, okay, from 1 to 3 over here, so somewhere in that gap, it changes concavity. And like we just saw in the last one, we kind of confirmed that already. We said, yep, it went from positive to negative. I know it changed concavity in there. It did change. Whether or not 2 is the only place it changed, I don't know. It could have changed concavity 5 or 6 times in between there for all we know. But we do know for sure that it absolutely 100% did change between 1 and 3 on that interval someplace. So of all the answers, the only one that 100% must be true is that the graph changed concavity. So D is a hard one to say no to on a test. I get it. But remember that when you're dealing with tables, you're only seeing such a small window of what's absolutely possible. So don't assume anything on a table. Thanks for watching my video. If you liked it, please click that like button and subscribe. And also share it with your friends and anyone else you know who might be crying about an upcoming AP Calc test. You can find more videos from me, more sample AP Calc questions, and my complete AP Calc study guide over at my website, apcalcprep.com. Have a great one.